Welcome back. Ms. Shinsato did last unit. It's back to being me, Mrs. Kohler, doing this unit. And we are going to be starting Unit 4 today. And this is going to be on factoring. Factoring and more trigonometry. Okay. And I believe the last page Ms. Shinsato labeled was page 26. So let's go ahead and call this page 27. I'm sure it's not exactly page 27 in your notebooks, but we're just going to call it that. And let's add this to our table of contents. So we'll put Unit 4. And I'm going to go ahead and write down the first page because we're definitely going to put page 27, which will be on factoring. Okay, that definitely needs to go on your table of contents. So we are going to be talking about factoring, so let's flip back and let's go to the next available page. And these notes are going to be on factoring. Factoring is definitely one of, if not the most important thing that you will learn in Integrated 2. From now on, we pretty much use factoring every day in this class. So it is absolutely vital that you know how to do this. So we're going to start with a little sentence. It's going to be a polynomial in the form ax squared plus bx plus c. Now, x's are your variables, a, b, c. Those are actually numbers, a and b being coefficients and c being a constant, which we're going to talk about those words again. That is called a quadratic expression. And that's written in standard form. Okay, so that's a quadratic expression. I spelled that wrong, I apologize. Quadratic. There we go. Quadratic expression in standard form. And this word quadratic, again, is a very important word that we're going to be using all the time now. So I just introduced two things. We have ax squared plus bx plus c, and that's a quadratic expression. Okay? And then the process of changing a sum, which is adding like this, to a product, which is multiplication, is called factoring. And that's what we're going to be learning today, is how to factor. Okay? When you see a quadratic expression, it's going to look very similar to what we end up when we're doing area models. So area models is multiplication. Factoring is actually going to be the opposite of that. Okay, so we're going to write ax squared plus bx plus c. That's our quadratic expression, but we're going to turn it into something like this. So this is a sum. This is standard form. And this is written as a sum because we have addition right there. And this is it in factored form. And this is the product because they're multiplying in between those two. Okay, so we're going to be given something like ax squared plus bx plus c. We're going to have to factor it and then put it into factored form. Okay, so these notes I am going to give you step-by-step instructions on how to do this, okay? And I would suggest when we're doing this the first couple times not to skip steps, to just go through it. It may seem a little tedious, but I promise if you follow the steps, you're going to get the right answer, okay? So let's start with an example. Okay, we're going to factor 2x squared plus 5x plus 3, okay? So we have the standard form. We want to make it the factored form, okay? That's the whole purpose of this. Okay, so our step one. Step one is going to be to make an area model. And excuse me, we all know how to make an area model. It looks the exact same. So we're going to make a box. Okay. We have an area model, just like we always do. Okay. You make an area model. Step two. You're going to put the first and last terms in the diagonal boxes. Okay, now I wrote it in words. You're going to put the first and last terms in diagonal boxes. Now let's see what that looks like. This is the first term. This is the last term. You'll notice I included the plus sign. That's to tell me what symbol goes there. In diagonal boxes. So I'm going to put 2x squared, and then in the diagonal box, plus 3. Okay? Put the first and last term in diagonal boxes. Step 3. Multiply the diagonal. Okay? So we're going to take these and we're going to multiply them together. So we do 2x squared times plus 3, and that's going to give us 6x squared, and I'm going to write it right there. Multiply the diagonal, 2x squared plus 3 is 6x squared. Step 4. Make a diamond. So the 6x squared, or whatever's up there, right? It's always not going to be 6x squared, is in the top. Okay? So that's going to look like that. Diamond, cross, whatever you want to call it, okay? So we have that diamond. And then I'm going to do the same step, and I'm going to put a little dash here, and you're going to put the middle term in the bottom. So this middle term, the 5x, that's going to go down into the bottom. So plus 5x. So we make the diamond, so the 6x squared's in the top, and then we put the middle term down in the bottom. Excuse me. Okay? So, step 5. You need to find something that multiplies to the top number and adds to the bottom number. Now, this may seem very familiar. If I flip back in my notes, page 2 is diamond problems. Let's go to page 2. Look at that. The top number, multiply. The bottom number you're adding, that's when you're finding x and y. This is the same thing as we've done on the diamond problems. Okay, that's why we started with diamond problems, because it leads to this. We have to find two numbers that multiply to 6x squared and adds to 5x. I want you to think about that right now. What multiplies to 6x squared and adds to 5x? Okay, so hopefully you figured out that it is 3x and 2x. Let's go ahead and write down the steps right there. Find two numbers that multiply to the top and add to the bottom. Okay, and again, that's going to be 3x and 2x, because 3x times 2x is 6x squared. 3x plus 2x gives me that 5x. Okay, and then you're going to put those in the diagonals, the other diagonal. So now the 3x and the 2x are going to go here and here, and you'll notice I did put pluses. You can absolutely put pluses here to remind yourself that they're both positive. You could write 2x and 3x, 3x and 2x. It does not matter the order. You'll get the same answer. Now the sixth step is, I'm going to say find the greatest common factor for a round. Now again, we've done this. This has been on your test where you have to find what goes around. Okay, so I'm going to write find the greatest common factor for each part. Okay, so let's do this together. I'm going to cover this part up, and I'm just looking at that column. 2x squared and 3x. You have to think, what do those have in common? Well, what do 3x and 2x squared have in common? They both have an x. Okay, now I'm going to cover up this column. What do 2x and 3 have in common? That one's a little harder. They have a plus 1 in common, because if I can divide a 1 into both of those. Let's do this row. 2x squared and 2x. Those both have a 2x in common. And then 3x and 3 both have a 3 in common. That's your answer. What we have written outside is your factored form. We write 2x plus 3 times x plus 1, and that's going to equal our original problem, which was 2x squared plus 5x plus 3. And that is your answer after factored. Now I do want you to do one problem, okay? So if you don't have room on this page, that's okay. Oh, you know what? I didn't put page 26. I apologize. Excuse me, page 27. I think I messed up on that, but that's okay. Okay? So if you need to flip it over, that's okay. But I want you to try this problem. Okay, so go ahead and do this one. You're going to factor 2x squared plus 7x plus 3. Go ahead and do that, enter in your answer, and then press play, and you can see if you did it right. Okay? So now I'm going to go over it. So the first thing, like I said, you need to make your area model. We put the first term and the last term in the diagonals, and then we multiply. And we get 6x squared. It just happens to be 6x squared. It's not always going to be 6x squared. Make our diamond, and we put that middle term in the bottom. Okay. Now we need to decide what multiplies to 6x squared, adds to 7x. Hopefully you got 6x and 1x. You can absolutely put plus signs if that helps. So I'm going to put that in here because that goes on the diagonals as well. And then you need to find the GCF. So what goes around? 2x squared and 6x, those have a 2x in common. 1x and 3, those have a 1 in common. 2x squared and 1x have an x, and then 6x and 3 have a 3. So now our answer is 2x plus 1 times x plus 3 equals 2x squared plus 7x plus 3. Okay? And that's how you factor.